I'm gonna tackle about the properties of transpose. So the properties of transpose have four properties. These are transpose of the transpose matrix, addition property of transpose, multiplication by constant, and multiplication property of transpose. So we have here the first property of transpose, which is the transpose of the transpose matrix. So we have here the transpose of transpose A is equals to A, which is the original matrix. So we have here letter A, which is the original matrix, is 1, 3, 2, and 4. So we have to transpose it, and we're going to tag it as the transpose of A. Enable for us to transpose matrix, we have to get the first row, which is 1 and 3, and make it the first column of the transposed matrix. So we have here 1, 3, and now we have here 1, 3 as the first column of the transpose A. And we have to take the second row of the original matrix, which is 2 and 4, and make it the second column of the transposed matrix, which is 2 and 4. Enable for us to get the transpose of transpose A, we have to take the same procedure, which is to take the first row of the matrix, which is 1, 2, and make it the first column of the transposed matrix. So we have now here the 1 and 2 as the first column of transpose A. And now we have to take the 3, 4, which is the second row of transpose A, and make it the second column of the transpose of transpose A, which is now the 3 and 4. So therefore, transpose of transpose A is equals to A, which is the original matrix. Now we have here the second property of transpose, which is addition property of transpose. So we have here transpose of A plus B is equals to transpose A plus transpose B. For example, we have the matrix A, which is 1, 2, 3, 4, and matrix B, which is equal to 5, 6, 7, and 8. So A plus B, we will have to add up the matrices. So we have here 1 plus 5, 3 plus 7, 2 plus 6, and 4 plus 8. So if we sum up this, we were gonna get 6, 8, 10, and 7. So now we have to transpose it, and with the same procedure, we have to take the first row and make it the first column of the transpose matrix, and get the second row and make it the second column of the transpose matrix. So in this case, the first row is 6 and 10. Now we have to make this as the first column of transpose A plus B. So we have here 6, 10. Sorry. So the second row is 8, 12, and we have to make this as the second column of the transpose A plus B. So we have here now the 8 and 12. So second is the A transpose of A plus transpose of B. So the transpose of A is 1, 3, 2, and 4, and 5, 7, 6, and 8. So we're going to add up this, and we got 1 plus 5, 2 plus 6, 3 plus 7, 4, and 8, which is right here. And the transpose of A plus transpose of B is equals to 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, and 4 plus 8 is 12. Therefore, the transpose of A plus transpose of B is equals to transpose of A plus B. So now the third property of transpose is the multiplication by constant. So we have here the transpose of K times A and the transpose of K A, where K is a constant. So we have here the original matrix, which is A is equals to 1, 4, 2, 5, and 3, 6, and K, which is a constant. Then the transpose of Ka, so we have to allocate K in every number in matrix A. So we have here 1K, 4K, 2K, 5K, 3K, and 6K. So we have to get the transpose of this, and we're going to have the 1K, 2K, 3K, 4K, 5K, and 6K. Now, the transpose of K times A is equals to K and the matrix 1, 2, 3, 4, 5, and 6. So the total or the product of transpose of K times A will be equal to 1K, 2K, 3K, 4K, 5K, and 6K. Therefore, we conclude that the transpose of K times A is equals to the transpose of K times A. Now we have here the fourth property of transpose, which is the multiplication property of transpose. So we have here the transpose A and B is equals to transpose of B and transpose of A. For example, we have here the matrix A, which is 1, 3, 2, and 4. The matrix B, which is 5, 7, 6, and 8. So we have here the transpose of AB. So we're going to do is like the same manner. We have to get the first row and make it the first column of the transpose matrix. So we have here 1, 2, 3, 4, and 5, 6, 7, and 8. So now we have to multiply the matrix to get the matrix or the transpose of A and B. So we have here 1 times 5 plus 3 times 6. The next is 2 times 5 and 4 times 6, which is shown here. And the next is 1 times 7 plus 3 times 8, which is right here, and 2 times 7 plus 4 times 8, which is here. So we have to sum this up or get the product. So we have here 1 times 5, which is 5, plus 3 times 6, which is 18. So 18 plus 5, we have here 23. Now 2 times 5 is equals to 10. 10 plus 6 times 4, which is 12, or 6, 12, 6, 12, 18, 24. 24 plus 10 is equals to 34. So now 1 times 7 is equals to 7 plus 3 times 8, which is 8, 16, 24. 24 plus 7, which is equals to 31. And we have here 2 times 7 is equals to 14, and 4 times 8 is equals to 8, 16, 24, 32. 32 plus 14 is equals to 46. So we have the transpose of AB is equals to 23, 34, 21, and 46. Now we have here the transpose of B and transpose of A. So now the values of the matrix of transpose of B and transpose of A is equals to 1, 2, 3, 4, 5, 6, 7, and 8. So in the same manner, we have to multiply 1 times 5 plus 3 times 6, 2 times 5 plus 4 times 6, 1 times 7 plus 3 times 8, and 2 times 7 plus 4 times 8, which is right here. So we have to get the product and The same manner, it is 1 times 5 plus 6 times 3 is equals to 23. 2 times 5 plus 4 times 6 equals to 34. 1 times 7 plus 3 times 8 is equals to 31, and 2 times 7 plus 4 times 8 is equals to 46. So here the transpose of AB has 23, 34, 31, and 46, and transpose of B and transpose of A has 23, 34, 31, and 46. Therefore, the transpose of AB is equals to transpose of B and transpose of A. Thank you.